I have a dream that one day
Hi there everyone, welcome to the second and last lesson on quadratic inequalities. In this lesson, we want to look at the last standard technique on quadratic inequalities, namely quadratic inequalities that involve trinomials. Example 4 on quadratic inequalities deals with trinomials, and it says solve for x in each of the following inequalities, and we are given these 7 inequalities. So let's look at the first one. So we have x minus 2 times x minus 1 is strictly greater than 6. Now we always need a 0 on the right hand side of a quadratic inequality. So we're going to start by multiplying out the brackets on the left hand side. So x times x is x squared. Then we have negative 2x minus x is negative 3x. And negative 2 times negative 1 is positive 2. We're also going to bring the 6 to the left hand side. So now we can add like terms. So it's x squared minus 3x. 2 minus 6 is minus 4. Now that we have the left-hand side in standard quadratic form as a trinomial, we can factorize. And it's going to be x minus 4 times x plus 1. This is strictly greater than 0. Now we can draw a rough sketch of a parabola. Our roots will be negative 1 and positive 4. So let's draw the sketch. So this is the parabola, and the roots are, as we said, negative 1 and positive 4. Now we want the left hand side to be strictly greater than 0. Another way of putting that is that the parabola must be positive or above the x-axis. And we see that to the left of negative 1, the parabola rises above the x-axis, as well as to the right of 4. So also here it rises above the x-axis. Now we can write down our answer. So x will be less than negative 1, or x will be greater than 4. If we express this in interval notation, it will look as follows. It will be the union of these two intervals. So x will be an element of the interval from negative infinity to negative 1. So the union of this interval with this interval, so union, then 4 to positive infinity. Let's look at the second inequality. So we have x into 2x minus 3 is less than or equal to 2. Once again, we need a 0 on the right hand side, and we're going to multiply out the left hand side to get this in standard quadratic form. So it's 2x squared minus 3x, We want to bring the 2 to the left-hand side, so it's minus 2 less than or equal to 0. Now that we have a 0 on the right-hand side, and the left-hand side is in standard quadratic form, we can factorize. So we need a middle term of negative 3x. 2x times 2 will give us 4x. So the minus goes here. And then we need plus 1x to get negative 3x. This is less than or equal to 0. Once again, we can draw a rough sketch of a parabola. Our roots in this case will be negative a half and positive 2. And we get the roots by taking the contents of each of the two sets of brackets and making it equal to 0. So we'll say 2x plus 1 is 0, and then we'll solve for x to get negative a half. And here we'll say x minus 2 is equal to 0, and we'll get x equals positive 2. So the roots are negative a half and positive 2. So just drawing the parabola. So it's negative a half and positive 2. In this case, we want the parabola to be less than or equal to 0. In other words, either 0 or negative or below the x-axis. So we can see that the parabola is 0 at negative a half and at 2, and it's below the x-axis or negative between negative a half and 2. Now we can write down the answer. So x will be greater than or equal to negative a half, but less than or equal to 2. In other words, over this part of the x-axis. Once again, if we had to write this in interval notation, we can write that x is an element of this closed interval. In other words, including negative a half and positive 2. So this closed interval from negative a half to 2. Let's look at number 3. So we have negative 3 multiplied by x plus 1 and by x minus 3. And it's less than 0. In this case, we do have a 0 on the right-hand side, but negative 3 here is a constant coefficient of these two brackets, and we can get rid of it by dividing it into the right-hand side. So then x plus 1 times x minus 3 will be, and when we divide through by a negative number in an inequality, the sign will switch around. So it will be greater than 0. Now we can draw the parabola. The roots in this case will be negative 1 and positive 3. So negative 1 and positive 3. In this case, we want the parabola to be positive, greater than 0, or above the x-axis. And once again, this occurs to the left of negative 1. So to the left of negative 1, it rises above the x-axis, as well as to the right of 3. So then our solution will be x is less than negative 1, or x is greater than 3. If we were asked to write it in interval notation, it will be the union of these two intervals. So x is an element of this open interval from negative infinity to negative 1. So the union of this interval with the interval that goes from 3 to positive infinity. Then coming to number 4, we have x squared minus 5x is strictly greater than 0. In this case, we can take out a common factor on the left-hand side. It's going to be x into x minus 5, strictly greater than 0. We do have a 0 on the right-hand side, so we can actually draw the parabola at this stage. The roots will be x equals 0 and x equals 5. So let's draw the parabola. So x equals 0 and x equals 5. So something like this. With 5 over here. And we want the parabola to be positive or greater than 0. In other words, above the x-axis. Once again, this happens when x is greater than 5 or when x is less than 0. So our answer then will be x is less than 0 or x is greater than 5. And once again, we could express this in interval notation as the union of these two intervals. Let's look at number 5. So here we have 6 plus x minus x squared is greater than or equal to 0. We do have a 0 on the right-hand side, and we have a trinomial on the left-hand side, but we want to write it in standard quadratic form. In other words, with the x squared first, then the x, and then the 6. So it's going to be minus x squared plus x plus 6 greater than or equal to 0. Before we factorize, we want to get rid of the minus in front of the x squared. So we're going to multiply through by negative 1. Of course, then the inequality will switch around. So we have x squared minus x minus 6 less than or equal to 0. Now we can factorize the left-hand side. It's x minus 3 times x plus 2. So we can draw the parabola now. And in this case, the roots will be positive 3 and negative 2. So let's draw the parabola. So just a rough sketch. So we said negative 2 and positive 3. In this case, we want the parabola to be either equal to 0, which is at negative 2 and positive 3, or less than 0, in other words, below the x-axis, which is this region. And we can see that the parabola is below the x-axis for all x's between negative 2 and 3. So then our answer will be x is greater than or equal to negative 2 or less than 3. So it's sandwiched inequality. And we could express it in interval notation as x is an element of this closed interval. In other words, including negative 2 and 3. So we're using square brackets to show that we are including negative 2 and 3. So this closed interval from negative 2 to 3. Let's look at number 6. So here we have 3x squared minus 3x minus 4 is less than or equal to 0. We do have a 0 on the right-hand side, and we also have a trinomial on the left-hand side. The problem here is that we can't factorize the left-hand side. We're going to use the quadratic formula to find x with. So we're going to turn this into an equation first in order to find the roots. So I'm going to say 3x squared minus 3x minus 4 equals 0. And now we're going to use the quadratic formula. Now, remember the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we can plug into the quadratic formula. So x will equal minus b. So minus negative 3 is positive 3. Plus or minus or rather b squared will be minus 3 squared minus 4ac. And this is all over 2a. So 2 times 3. We can work out what's under the square root, and it's going to be 57. So the square root of 57 all over 6. So in this case, x is equal to 3 plus the square root of 57 all divided by 6, or x is 3 minus the square root of 57 all divided by 6. We can work out these on a calculator. So 3 plus the square root of 57, then divided by 6. And it's 1,76 corrected 2 decimal places. So 1,76. And we also want 3 minus square root 57 divided by 6. And it's negative 0,76. So negative 0,76. These are the roots then when we solve for x in this equation. So now we can draw the parabola. We do have our roots. Our roots will be 1,76 and negative 0,76. So negative 0,76 and 1,76. Now, the original inequality says that the left-hand side, which is also an equation of the parabola, must be less than or equal to 0. So it's 0 at these two numbers, negative 0,76 and 1,76, and negative or below the x-axis for this region, for all x's between these two numbers. So we can write down our answer then to the original inequality. So I'm going to say for the original inequality, 3x squared minus 3x minus 4, less than or equal to 0. So 3x squared minus 3x minus 4, less than or equal to 0. And we said that x is between these two numbers and inclusive of both. So x will be greater than or equal to negative 0,76, but less than or equal to 1,76. Let's look at the last inequality. We have 2x squared minus x plus 3 strictly greater than 0. We do have a 0 on the right-hand side and a trinomial on the left-hand side. So we don't have to do any further manipulation. The problem here is that we can't factorize the left-hand side. So we're going to use the quadratic formula. So x equals negative b, which is minus negative 1, so 1, plus or minus the square root of So the square root of b squared, which is negative 1 squared, minus 4 times a times c. This is all over 2a. So let's see what that comes to. So it's 1 plus or minus. Then under the square root, we'll get negative 23. And this is all over 4. We know that the square root of a negative number is non-real. So what it tells us is that the solutions to this quadratic are actually non-real. In other words, the parabola represented by this quadratic won't have any roots. Now, the x squared coefficient is also positive. So we know it's a parabola that smiles like a positive person. In other words, it has a minimum value. So a minimum value. And the fact that x equals 1 plus or minus the square root of a negative number, we said, tells us that this parabola doesn't have any roots. So let's look at the drawing of it. So we know it smiles and it doesn't have any roots, so it doesn't cut through the x-axis. So it's going to look something like this. Now, in this inequality, the left-hand side here is strictly greater than 0. And we need to find for which x values the left-hand side is greater than 0. In other words, for which x values will this parabola be positive or above the x-axis? And from the sketch, we can see that it's going to be positive or greater than 0 or above the x-axis for all x's. So in this case, our answer is x is an element of real numbers. Once again, if we had to express this in interval notation, it will be x is an element of this open interval from negative infinity to positive infinity. Let's look at your answers to this question. In A, we have x into x plus 4 is less than or equal to 2x plus 15. We can start by multiplying out the left-hand side and also bring all the terms to the left-hand side. Now we can add like terms. We can factorize because we have a 0 on the right-hand side, and the left-hand side is written in standard quadratic form. So at this stage, we can always factorize. So x plus 5 times x minus 3 less than or equal to 0. So we can see that the roots of this trinomial or quadratic will be negative 5 and positive 3. We can draw the parabola now with those roots. So it's negative 5 and positive 3. So just a rough sketch. We want the parabola to be negative or less than 0, either negative or less than 0, or equal to 0. So we can see that this parabola cuts the x-axis at negative 5 and 3, so it's 0 at these 2 points, and it's below the x-axis or negative over this region. In other words, for all x's between negative 5 and 3, it's below the x-axis. So we can write down the solution. So x will be greater than or equal to negative 5, but less than or equal to 3. Let's look at B. We have 5x minus 3x squared, strictly less than 0. We're going to start by rewriting the order of the terms on the left-hand side. So we're going to write the term in x squared first. So negative 3x squared plus 5x less than 0. We also want to get rid of the minus here in front. So we're going to multiply through by negative 1. We always try and work with a positive x squared coefficient. So it's 3x squared minus 5x. And the inequality will switch around when we multiply through by a negative number. So this will be greater than 0. Now we can take out a common factor of x in the left-hand side. And we're left with 3x minus 5 is greater than 0. So the roots of this quadratic will be x equals 0 or x equals 5 over 3 when we solve this inside the brackets. So when we make 3x minus 5 equal to 0, we end up with x equals 5 over 3. So that's going to be the one root. And the other root will be when we make x equal to 0. So then 0 will be the second root. So now we can draw the parabola. So it's 0 and 5 over 3. Something like this. So this is 5 over 3 over here. We want the parabola to be positive or above the x-axis. So we see that to the left of 0, it rises above the x-axis for all x's less than 0, as well as for all x's greater than 5 over 3. Here it also rises above the x-axis, so it's positive. So we can write down the answer. So x will be less than 0. In other words, all these x's below 0. X is less than 0, or x will be greater than 5 over 3. So basically all the x's above or to the right of 5 over 3. Then coming to C, we have 12 minus x squared is less than 0. Once again, we're going to rewrite the order of the terms on the left-hand side with the x squared first. So it's negative x squared minus x plus 12 less than 0. Now we're going to multiply through by negative 1 in order to get a positive x squared coefficient. So it's x squared plus x minus 12, and the inequality will switch around, so greater than 0. We can factorize. And now we can draw the parabola again. And our roots will be negative 4 and positive 3. So negative 4 and positive 3. So something like this. Negative 4 and positive 3. Once again, we want the parabola to be positive or above the x-axis, And we can see that it's to the left of negative 4. So for x values to the left of negative 4 and to the right of 3. So just writing down the answer then, x is less than negative 4. So all these x values, or x is greater than 3. In other words, all these x values. Let's look at D. We have x squared minus 2x minus 5 is greater than or equal to 0. The left-hand side is in standard quadratic form, and we have the 0 or a 0 on the right-hand side. But when we try and factorize the left-hand side, we see that it doesn't factorize. So we're going to use a quadratic formula, x equals negative b or minus b, plus or minus the square root of b squared, minus 4ac, all over 2a. So I'm going to solve this first as an equation in order to get the roots. So we're going to say for x squared minus 2x minus 5 equal to 0. Then using the quadratic formula here, it's going to be negative b so negative minus 2 or minus negative 2. So it's 2 plus or minus the square root of negative 2 squared minus 4ac. A is 1 and c is negative 5. 4ac. This is all over 2a. So 2 times 1. We can first work out under the square root, and it comes to 24. So we see then that x is equal to 2 plus the square root of 24 all over 2, or x equals 2 minus the square root of 24 all over 2. Now we can use a calculator. So 2 plus square root 24 divided by 2, and it's 3,45. So 3,45. Then 2 minus the square root of 24 divided by 2 is minus 1,45. So minus 1,45. We now have the roots of the quadratic x squared minus 2x minus 5. So now we can draw a parabola. And our roots are negative 1,45 and 3,45. So something like this, negative 1,45 and 3,45. Now we can go back to the original inequality. So I'm going to write for an original inequality is x squared minus 2x minus 5 greater than or equal to 0. So x squared minus 2x minus 5 greater than or equal to 0. We can write down the solution. We want the parabola to be either equal to 0 or positive. In other words, above the x-axis. And we can see that at these 2 points, the parabola is equal to 0, or the quadratic is equal to 0, and to the right of 3,45, as well as to the left of negative 1,45, it rises above the x-axis. So then our answer will be, so x is less than or equal to negative 1,45. In other words, all these x's to the left and including negative 1,45. Or x will be greater than or equal to 3,45. In other words, all these x's to the including 3,45 and to the right of 3,45. So this is our answer then. Then coming to E, we have 3x squared minus x plus 1 is strictly greater than 0. The quadratic on the left-hand side once again doesn't factorize, so we can try and use the quadratic formula. So x equals minus b, so plus 1, so minus negative 1, plus or minus the square root of minus 1 squared minus 4ac. This is all over 2a, so 2 times 3. So we have 1 plus or minus the square root of, and we can work out under the square root. It's going to be 1 minus 12, which is negative 11 all over 6. So we see that in this case, we get the square root of a negative number, which is non-real, and it means that this quadratic doesn't have any real roots. Now, what's also important to note is that the x squared coefficient is positive. In other words, it's a smiling parabola, like a positive person. It has a minimum value. So we can draw a sketch of this parabola. So we don't have any roots, and as we said, the parabola has a minimum value. It's a smiling parabola. In other words, it's going to look something like this. It's going to be drawn entirely above the x-axis. So something like this. So no roots. It doesn't intersect the x-axis. Now, we want to know where this parabola is positive. In other words, above the x-axis. For which x values will it be above the x-axis? And we can see that for all x values. So then our answer in this case will be x is an element of real numbers. So the entire real line, the entire x-axis. Let's look at F. We have x minus 2 times x minus 1 strictly greater than 6. We don't have a 0 on the right hand side, so we're going to multiply out the left hand side and then bring the 6 to the left hand side as well. So it's going to be x squared minus 3x plus 2 less 6 is greater than 0. So then we have x squared minus 3x minus 4 greater than 0, which we can factorize. So greater than 0. We can now draw the parabola. In this case, our roots are negative 1 and positive 4. So negative 1 and positive 4. -1 and +4. And we want the parabola to be above the x-axis, since this inequality says that the left-hand side is greater than 0 or positive. So once again, it's going to be to the left of -1 and to the right of +4. So we can write down our answer. X will be less than -1 or greater than 4. Let's look at the last inequality. So G. Here we have 18 minus 2 into x minus 1 all squared is greater than or equal to 0. We can start by dividing through by the common factor, which is 2 in this case. So we can divide through by 2. So 2 into 18, 9 times. Here the 2's will cancel. So we're left with 9 minus x minus 1 all squared greater than or equal to 0. Now we could proceed by squaring out the brackets, adding like terms, and then getting a quadratic in standard form on the left-hand side. I'm going to choose a different way of doing this. I'm going to let x minus 1 equal k. So then we end up with 9 minus k squared is greater than 0 or greater than or equal to 0. And this, of course, is a difference of squares, which we can factorize as such. So it's going to be 3 minus k times 3 plus k greater than or equal to 0. Now, we can draw a parabola for this. So for the left-hand side, our roots in this case will be -3 and +3. This is when we solve the contents of each of these two sets of brackets, when we make the contents equal to 0 and we solve for k. So we see that it comes to positive or -3. Of course here, this is really the k-axis. So we should write k here. So then let's draw the parabola. It's plus and minus 3, the roots. So it looks something like this. -3 and +3. And once again, we want the parabola to be positive. In other words, above the x-axis. So either positive or above the x-axis or equal to 0. It's equal to 0 at positive and -3. And it rises above the x-axis to the left, for x is to the left of -3 and to the right of +3. So we can solve then for k. K is going to be less than or equal to -3, or k is going to be greater than or equal to +3. Now, the original inequality, of course, is in terms of x, and here we have answers in terms of k. So we're going to substitute back in for x. So where we have k in these two inequalities, we're going to write x minus 1. So x minus 1 is less than or equal to -3, or x minus 1 is greater than or equal to 3. And now we can solve for x. X will be less than or equal to -2, or x will be greater than or equal to 4. This being our final answer. Let's look at your answers to this additional question. In A, we have x squared plus 2px plus p squared strictly greater than 0. It's important to recognize that this is a perfect square on the left-hand side, because the first term is a perfect square, the third term is a perfect square, and the middle term is twice the square root of the first term times the square root of the third term. So we can factorize it as such. So we take the square root of the first term, which is x, the middle term sine, and the square root of the third term, which is p, and this is all squared, so it's greater than 0. We must find the value of x for which the left-hand side here is strictly greater than 0. We know that the perfect square is going to be either 0 or positive. In this case, we want it only to be positive. So the question now is, for which value of x will the contents of the brackets or the bracket be 0? We know that x plus p equals 0 when x is negative p. So solving this equation. In other words, if x is negative p, then we'll get 0 on the left-hand side, and the left-hand side won't be strictly greater than 0. For any other values of x, because we have a perfect square, for any other values of x besides negative p, the left-hand side here will be positive. So then our answer is x is an element of real numbers, but excluding negative p. We can also write this in interval notation as follows. X will be an element of the union of two intervals. The first interval is from negative infinity to negative p. So union. And the second interval will be from negative p to infinity. Let's look at B. So in part 1 of B, we have to solve this inequality. And we're going to start by multiplying the x into the brackets on the left-hand side. We can also bring the 24 to the left-hand side. Now we can factorize. And we can draw a parabola. Now, the roots of the parabola will be negative 6 and positive 4. So negative 6 and positive 4. Something like this. Negative 6, positive 4. We want the parabola to be strictly below the x-axis, or negative. And we can see that for this region, it dips below the x-axis. So then for all x's between negative 6 and 4, the parabola is below the x-axis. So now we can write down the answer. So x will be greater than, or rather just greater than, negative 6, but less than 4. In interval notation, it will look as follows. X is an element of this open interval from negative 6 to 4. So not including negative 6 and 4. So we use round brackets. Then in part 2 of the question, it says, hence determine the sum of all the integers satisfying this inequality. So we need to add up all the integers between negative 6 and 4. So we can draw a number line for ourselves. So all the integers between negative 6 and 4, it's going to be negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So 3 as well. We have to take the sum of all these integers. Now we can see that some of them will cancel when we add them. Negative 3 will cancel with 3, negative 2 with 2, negative 1 with 1. So we only have to add negative 5, negative 4, and 0. So then our answer will be negative 5 plus negative 4 plus 0, and this is negative 9. Let's look at the last question. So in part 1 of C, we have to solve this inequality. So we can factorize the left-hand side. Now we can draw the parabola. Our roots in this case will be negative 3 over 2. When we make 2x plus 3 equal to 0 and we solve for x, we get negative 3 over 2 and x equals 5, which we get by making x minus 5 equal to 0 and solving for x. So the roots are negative 3 over 2 and 5. So let's draw the parabola. It's going to look something like this. So negative 3 over 2 and 5. And this, of course, is just a rough sketch. Now, we want the parabola to be either greater than 0, in other words, positive, or equal to 0. And we can see that at negative 3 over 2 and 5, it will be equal to 0. And for values less than negative 3 over 2 and greater than 5, it rises above the x-axis. In other words, it's positive. So we can write down our solution. X will be less than or equal to negative 3 over 2, or x will be greater than 5, greater than or equal to 5. Now, the question did say, give your final answer in interval notation. So let's do that. So once again, x will be an element of the union of these two intervals. X is an element of the first interval, which will be from negative infinity to negative 3 over 2, but including negative 3 over 2. So we use a square bracket. So it's this interval, the union of this interval with the second interval, which is this one. X goes from 5, including 5, to positive infinity, but always excluding positive and negative infinity. So this is the first part of the question. Let's look at the second part. It says, hence or otherwise determine for which positive values of x this expression will be real. So let's start by writing down the expression. So it's basically the square root of the left-hand side of this inequality in the numerator. So the square root of 2x squared minus 7x minus 15 all over x minus 8. So just to go back to the question, it says determine for which positive values of x this expression will be real. Now, there are two things of importance. Firstly, whatever's under the square root can only be greater than or equal to 0, because we can't get the square root of a negative number. Then secondly, we can't divide by 0, so x won't be equal to 8, because then we'll get 8 minus 8 in the denominator, which is 0. Now, let's look at the first requirement. We said whatever's under the square root here must either be greater than or equal to 0. Now, we already solved this inequality. So 2x squared minus 7x minus 15 is greater than or equal to 0. And we saw for x values greater than or equal to 5, or for x value less than or equal to negative 3 over 2. This inequality, or the left-hand side of this inequality, will be positive. We are only interested in positive x's, so we are interested in this interval, x greater than or equal to 5. So we know for positive x values greater than or equal to 5, what's under the square root will either be 0 or positive. But x greater than or equal to 5 will include x equals 8, and we can't divide by 0. So then our answer will be x is greater than or equal to 5, but x cannot equal 8.